get going. So I want to show you a couple of handy things. We're going to have a session on outputting data and showing how you can get data into and out of Excel, but I want to show you some low-hanging fruit from that we already have in place. I mean, if you're like me, you know, these graphs and so on, they're great. They're really handy for looking at model behavior, but, you know, really you want to bring some of that data back for analysis and so on, right? And we're going to see how we can accomplish this at several levels. But one of the issues is that we'll often want to put these things back into Excel, for example, the data from this. Maybe it's the data at the final time or what have you. I'd like to show you a really quick and easy way to do that. And then we'll build on that, and we'll have more extensive data output in a later session, okay? So the first thing is, if you're running this model, you should be able to go to any of these charts, and you should be able to right-click on them. Hey, come on. Hey, come on. I'm not. Hey, come on. Oh, come on. It's exhibiting truculence now. Maybe. Okay, there we go. I don't know. That's really a weird. Okay, there we go. Okay, I just have to. It's something with my computer, maybe. Okay, copy all, and then we can go over and to something like Excel here. We can paste in, and it will actually paste the information that's summarized in the chart. Okay, so let's try that. Go to this chart here, copy all, go back to Excel, and we should be able to paste in. Do you see that? Just with the paste character, Control V. Huh? Does that appear okay? With yours? Okay. Okay, try it for the pie chart now. Copy all. And we can go back and we can copy the data that's in the pie chart. It will give the breakdowns proportionally as well. And then, now this chart, I've seen problems where, and I don't know if it's something with my Excel or whatever, but I do copy here, and it actually gives me some trouble. It puts it all in one line. Does it put it on one line for you, or does it do it properly? What I find is if I go paste it into here and then copy from that, it'll go fine. So, but there seems to be some variability by Excel version or what have you. Or do you folks, when you do that last one, when you do this histogram, does it paste properly into Excel? Sorry? Oh, okay. For the picture, ladies and gentlemen, you can output the picture, and the way to do that is you go like this. Okay, you do a similar thing, but you do copy chart image. Yes. You don't have copy all.
It's not allowing us to do copy all. I've got cut, copy, paste, and delete. I don't have all those options.
Okay, so you have a.
You have to run the model first because you're pulling data out of the running model, not just.
Oh yeah. Sorry, I neglected to mention that. I'm actually running the model when I run it. You can also copy the chart itself by copy chart image. Okay? Yes.
When I copy the histogram,
The single line?
I don't get all
And you do copy all. Month Cool. Okay, I'd like Dylan to look at that one. That's an interesting. So on his, the copy of the one fine, it just doesn't get the summary. Okay. Okay, ladies and gentlemen, let's go continue in to ply our craft. Okay. So the next thing I would like to cover with this model, with your lead, will be open population. There are populations where people are born and people die. Is that okay? Okay. I think this is an important component for this group. For people interested in life course perspectives, interested in chronic diseases. We're dealing not with weeks of model operation, but with years or decades. And I'd like to show how we can, within AnyLogic, rise to that occasion. Okay, and even flourish. Okay. So, ladies and gentlemen, I would like to build on this model with your leave. And I would remind you that the particulars of what we'll be doing probably won't rely heavily on what we've just added. The pie chart won't be a central feature of our analysis. So if anyone came in late and wants to get a model, my model from yesterday from the website, download it, you could always start there. And I don't think you'll be strongly disadvantaged. Okay. So, ladies and gentlemen, I would like to put in place a mechanism first for immigration, which is a phenomenon with which Australia is not acquainted. We're going to first have immigration, and then we're going to put in place mortality, and finally births. Does that sound okay? Okay. So let's go up to Maine. Go, as they'd say in the States, in New England, go down Maine. Okay. So we're going to go to Maine, in Maine, we're going to add something which is going to, at a certain rate, go off and do something. Its job in life is to fire off at a certain rate. And we saw a similar construct yesterday. I won't give you its name, that will be your job. But we added it yesterday to do reporting at regular intervals every year. What is that construct called? So we want this thing to go off, fire off at a certain rate. What would that be called? I'll give you a hint. It lies within the agent palette. What would that thing be called that fires off at a certain rate? An event. We're going to add an event. An event conceptually, don't be fooled by the name, because it could actually represent many events. Basically, it's an event schedule. It might just be one event, but it might be a series of events. Okay, so I'd like you to go to Maine, and I'd like you to drag in this event here, and we're going to call it immigration event. Okay? And I should spell it with appropriate capitalization. Okay. Now, you'll notice that with events in general, events are a key feature of AnyLogic. We use them all the time for reporting, but we also use them for many other common functions. In this case, what we're going to do is we're not going to have it be only occur once. It's going to actually occur many times. And specifically, we're going to set it to be a rate transition. Rate transition is the same concept. It's a hazard rate, going off at a certain time per year, a certain chance, probably per year, per 1 month, whatever your time unit of choice is. Okay, so a certain rate of things happen. And let's set this rate to be, let's say 10. We can choose our time unit here of choice. We'll make it, we could say, 120 per year, or we could say, let's make it 5 per month, okay? 5 times per month on average. So rate firing off. It's memoryless. The time between events is exponentially distributed. it exhibits Poisson arrivals. These are all terms from stochastic processes that describe this. There's nothing specific to AnyLogic. There's all literature behind stochastic processes associated with hazard rates. These are arrivals. These are lambdas in a process for which things are arriving. Okay. And the job of an event in life is to do something when it triggers. So you tell it when to trigger. You declare, okay, I'd like this to trigger 5 per month or 5 per, or 60 per year. Those would be equivalent. And there's some action, and that action fires at those times where the event goes off. Just like that. It's firing off an action. And it's really the actions where the action's at. Okay? The action is where it's at. Okay, so we need to put something in the action that will do something. And therein lies the rub. Okay? Okay. So, ladies and gentlemen, what we're going to do there is something quite simple. We're going to say, well, our population, I would note, is called add population. So we're going to, it's called add population. So we're going to say add underbar population. If our population was called pop, we would say add underbar pop. And you'll notice that when we call this, there's 2 variables. And it asks us to specify either nothing for the person who's created, in which case we'll use just default values for the parameters, or we can specify the parameter values. In this case, we're going to specify this, we're going to choose this later version. And notice it gives us information over here. It says this method creates and adds a new embedded object in the object collection population. This method uses parameter values to set up the embedded object. Fancy terms. Basically what it means is you're going to add something into the population with the specified parameters. Right? So we're going to do this. And you tell me, what's the birth time going to be? We have to give it this information. For it to do its job, we need to give it the birth time. That's part of the contract. We give it this, and it will do its job of adding into the population. What's the birth time? What would the birth time be? This event is fired off. We got to add this person to the population. What's the birth time for that person? It's right now. It's right now. It's this current time. Do you see? I'm saying add to the population. Oh, actually, wait. Sorry, I'm confused. I'm sorry. Jeff has ways of saying this. I could say it must be the jet lag, but no, I think I'm just out to lunch. So, or judging by what time it is back in Saskatchewan, I'm out to late dinner. Okay. So, actually, that's not the birth time, is it? We don't want that to be treated like every immigrant is treated like a babe in the woods. They've just been born. That's not the case. We want their birth time to be drawn actually from a distribution because immigrants have a certain age profile. Some of them might be newborn babies, but others of them are older. Maybe they come in for work reasons. So, we could specify a distribution here. Do you want to do that? Okay. You folks are data-oriented as well, so let's go drag in a custom distribution. And this will be called age distribution. I was going to say age distribution for immigrants, but I think you'd prefer immigrant age distribution. What do you think about that? Okay. I hear support. Great. So immigrant age distribution was a custom distribution, and ladies and gentlemen, it was drawn from the agent palette. I need to project back to my computer. Okay. So I went to the agent palette and the Da Vincian emblem, and I dragged the custom distribution over here, and I call it immigrant age distribution. Now, what sort of distribution would this be? Remember when we used this yesterday for optionless? Remember we had people drawn with a certain probability, one sex or another sex? We chose options here. In this case, what type do you think it will be? will be a continuous one because we're drawing from their age. And we could specify this in a number of different ways, with frequency tables or with ranges, say between these certain ranges, we'll have these things. And you can kind of flip between these to get a sense. Here's observed samples. You can actually put a bunch of samples in, it will draw one of the samples. Or you can say here, okay, frequency table for a certain value would occur with a certain weight. But ranges is typically what we want for continuous. Okay? So maybe between 0 and 10 years old, 10. The number of observations is just a relative measure. So here, it'll normalize it automatically. So maybe 2 in that age category. We can specify this as finely as we want. From 10 to 20, it'll be perhaps another 3. And then from 20 to 25, quite a number of our young immigrants fall in that range, perhaps for university, etc. So maybe. Oh, wow! Thank you. Oh, gosh. Okay, thank you. Yeah. Then okay, thank you. 25. Okay, next one here, we'll go down, it autofills that. Notice 25 to 30, maybe there's another, a 7. This is just, so far it's just a little bit of a accent. This is rising. Between 35 and 40, there's another, well, let's say 35 to 30 to 35, there's 10, maybe there's 5 of those, and then 35 to 45, it's another, another 3, and then 45 to 55, it's another 2, and over 55, interval A, and here, I don't know, 100, we'll say 1. Okay.
Those intervals overlap.
They overlap?
Well, you've got, so your first
Yeah.
one, the interval ends at 10. And
That's
the
right.
second one starts at
That's
10.
right.
So is it
That's
going
right.
to, so when you've got somebody that's 10,
Yeah.
what's it going to do with them?
Well, again, this is continuous age, right? And so when you have continuous age, this is really a density for those regions. The chance that someone's exactly 10 years old is sort of infinitesimally small, the probability, but fundamentally they're going to have this, on a relative level, this probability, it's going to normalize it by the sum here, but between falling in this age category is another one falling in that age category. So basically, those edge cases, this is quite typical with a continuous thing, in contrast to a discrete thing where you'd say, from 0 to 9, age 0 to 9 exactly, use this, age 10 to 14, use this one, they never overlap. This, because it's continuous, it's not a real problem. Yeah. Okay, great question. Dylan.
I think the default behavior is that one of those ends is inclusive and the other one is exclusive. I can open any logic.
That'll be helpful.
But
Yeah.
for continuous, you're absolutely right. You would get right, effectively it would be the same thing for continuous one. You get right up to that edge within 0.00000001. So
Right.
for continuous, it makes no difference. But I think discrete, one end is inclusive and one is exclusive.
Okay, that's good to know.
Actually, as an aside to that, I tried to have my input ends as 0.0 and I made the others 0.1.
Oh?
And the thing has made, AnyLogic has made my input ends exactly the same as my input starts.
Right.
So everything is now 10.1, 20.1.
Okay, yeah. Okay, that's interesting. I think it wants you here, what it wants you to do is to give a quite collectively exhaustive and mutually exclusive things except for the endpoints. And so it actually does want you to cover it all because there'd be some probability that it will that it would fall within a range where you haven't specified. It wouldn't know what to do. So here we've drawn it. Remember, this is specifying essentially a probability distribution, a continuous probability distribution is what this is specifying. And this gives an indication of it. And it's not particularly privileged, right? But let's just draw this. This is our immigrant age distribution. We'll be able to call this, we'll say, generate for me an age of an immigrant. And it will generate from this. It'll draw from this distribution. It will sample from this distribution. Are we okay with that? Okay. Okay, ladies and gentlemen. So this immigration event, let's go back to that. Immigration event, what's the birth time going to be? If that's our age distribution, what's the birth time going to be such that they are currently this age? Okay, right now, I will tell you right now the current time is, we can get the current time by saying time. If they were born and they're now of this age, when must they have been born? Minus the immigrant age distribution, right? And we're going to call it. Note this. I need it to call for me. I need to say, do this, and it will return for me a double value. So I need to call it, and it will compute the value. There we go. Okay? So we're doing age population. We're saying, hey, let's compute this current time minus this age. Well, time is in years minus, so right now it's time 20. We pick from the immigrant age distribution, we call it here, it gives back 10. It's a child of 10 years old who's being added. Current time is 20 minus 10. They were born at time 10. 20 minus 10. They're born at time 10, and we say, hey, add them into the population. These parentheses are, again, just used to specify the information whatever we're calling needs to do its job. Does that make sense? It's like calling sine of 90 degrees. It needs the angle to do its job. So it is with the things in parentheses. We put them in parentheses for that reason, to indicate that. The parentheses hold what are called the arguments. They hold what are called the parameters. It goes by different names in programming lingo. Okay? Are we okay with that? Okay. Do you want to run this thing? What should we see? What should happen? What specter should lie before us? What do you think you'll see differently? Okay, we'll deal with the network. We can have these people woven into the network over time. We'll do that right now, because it's the most unpleasant prospect to see them being added without being in the network. Okay, so we're having our population grow. If we look at the population here, I would note here, ladies and gentlemen, if you go click on the population, it's rising. It's 1,400 agents, 1,500 agents. Here's the count of diabetics. Here's the count overweight, count obese. Where did these things, the count diabetic, count overweight, count obese, count normal and underweight, where did those come from? From whence did those come? Who created these? Did it know about overweight in the model inherent? Does AnyLogic know all about overweight, know about obese? No, it doesn't know about obesity inherently, the software package. So who created those? You did. You did. And you deserve to give yourself a pat on the back. You're the ones that added that. Those are the statistics that we added. Remember we added them to population? And that's when we click on population, we can see them. Another way we could see the population is growing is we can pull it down here. We'll see it kind of growing if I click here. Keep on clicking. Just like that. Okay? Are we comfortable with that? Okay. Do you want to add them into the network so that they're tied in with the network where they landed? Would you like to see that? Okay, I hear a certain indecision on that part. Do you want to see them in the network? Okay, thank you. The indecision has been broken, and we'll proceed post-haste. Okay, so for the action, we will want to do apply network. Okay, apply network. And I'd like to run this now. Apply network, okay? There we go. and I'd like to run the model now, and what you will see is now when they get added in, they're being added to the network. Do you see that? Sure. What I did is I went to the place from whence they are added to the population, to wit, this. And then after it, notice they stop with semicolons because we're telling it to do a command. Do this! Add them to the population. That's why we need that semicolon. We're saying, do it. We're not computing a value, determining it's not a formula. Instead, we're telling it, do this thing. It's what's called a statement. Okay? Do this. It's like an injunction, a command, an imperative order. And then we say apply network also with that. Are we okay with that? We add them in, okay? Okay, we're going to come more to networks today. But right now, that's what it's showing. Okay, so we've just added a population with immigration. What do you think? Good or not? Good. Okay, so now, and mind you though, I want to draw your attention to something. We've changed the character of the population. No longer are we dealing with a static population, do the dynamic. And for each person we added, we needed to specify their parameter values, right? We specified the parameter value, the birth time here. Now this is important. Do you remember when I told you two jobs the parameter has in them? To encode an assumption and to communicate that assumption from the point of creation to the thing with the parameter. So a person has a parameter here. I'll be with you just a second. Person has a parameter, and it's birth time. And so when we declared the population, we needed to specify the birth time. But also when we added these people in via immigration, we created them here. We're creating this new person. We need to tell it what the parameter, the value of that parameter is. It serves two functions: to encode the assumption, parameter for the person encodes it, but it also communicates that from where they're created, either from the population or from this point where they're added to the model. Yeah?
When you're adding the input population, how does the model know which state to start them in?
Now that is a great question. And that was, I'm going to go on and handle that. Why don't we handle that? Let's handle that now. Okay? Okay? Great question. Great question. Let's handle that right now. Okay. Ladies and gentlemen, I have several ways to handle this, and I'm going to handle it in the one that I find the cleanest, but it will require a slight bit of mechanism. Okay? And I apologize for that, but it will be clean. Okay, so ladies and gentlemen, I'm going to ask you to do this. Okay, I would ask you to go add an option list. How do I add an option list to this model? I want to have an option list where we say initial state normal glycemic or initial state diabetic, for example. Okay? Initial diabetes state, in other words. I want to have two possibilities for that. How would I add an option list to the model? Can anyone tell me? Anyone tell me? We do. It's actually quite familiar territory. New option list, or you can right click on this and do new option list, just like adding an agent or an experiment. Okay, new option list. And this will be called initial diabetes state. And there's going to be two possibilities. Okay, one of the possibilities is going to be initially normal glycemic. I right clicked on this and I did new option list. Right click on the model, or do file new option list.
Oh, I see.
Yeah. Yeah, and another one will be initially diabetic. Okay? Now, I'm actually choosing names. I know these seem wordy, and I apologize, but I'm choosing names that for a certain reason, so they won't clash with normal glycemic. It won't clash with diabetic. So if we say diabetic, you won't know which one do we mean, the initial one or the state name. I'm giving these names that will be distinct. Okay? Are we okay with that? Okay? Okay. Ladies and gentlemen, would you like me to leave that up for another minute? Should I leave it up there? Or are we ready to proceed? Proceed? Okay. Ladies and gentlemen, we will proceed. Click finish. My student, Kurt Kruger, tells me that he and I have the same tendency, to which I must restrain myself in this event. He says that when we teach, we actually draw energy from teaching. It's true, it expends energy, but we somehow have this source of energy that comes out and drives us to teach. And we thrive at it, but the way both of us have the same tendency that when we get enthusiastic, and you may have noticed I sometimes get enthusiastic about the material, both he and I have the tendency to show that enthusiasm in different ways, but one of the most pronounced ways is by raising our voice. And if I raise my voice in this way, for short time periods, it's no problem. But over the course of an entire day, if it is filled with enthusiasm and vim and vigor, I tend to burn out my vocal cords. And so I need to restrain myself in terms of my talking. He did make the mistake of also saying that the frequency or tone of my voice also rises, but then you realize that's a mistake. I don't talk like Mickey Mouse when I'm really excited. Okay, so that might be less hard on my vocal cords. So, okay, so ladies and gentlemen, we've just added this option list, and now what I'd like to do is to do the following. I'd like to add to this person a parameter that is called initial diabetes state with a lowercase I, okay? And I'm just going to futz it around, and probably by all justice I should move these things down and give this guy its own thing. Ladies and gentlemen, I'm more than willing to reveal for the crowd my weaknesses, and layout of a model, visual layout is not my foremost suit. And some students I've had are exquisite in this, but I have my failings, and this is one of them. Okay, so initial diabetes state. What do you think the type of initial diabetes state will be? This is with a lowercase I. What do you think its type will be? Anyone want to hazard a guess? Is it an acceleration, a speed? Is it a double? Is it a Boolean? Is it a what? What do you think it is? What do you think this is? What do you think this might be? What do you think it might be? What do you think the type of this is? What are the possible values it can take on, the initial diabetes state? It's going to tell this person what state to start in. What do you think the values are that it might take on? Okay, but so it could be yes, no. We could do it with yes, no. It's actually a perfectly, that would be a way to say it. We could say yes and no, but we wanted to handle this case as well, where it's not going to be merely yes, no. We actually just defined something called the initial diabetes state. Do you see that? So we'll use that, and that will tell us the legal values, and will allow us to be very clear, yes and no. We'll have to say, okay, yes means diabetes. Okay, in this case it's clear. In other cases it might not be clear what it is. But in this case we'll just give it the value, initial diabetes state, and that's the possible values it takes on. But this is the thing we just added. Remember that? Initially diabetic, initially normal glycemic. Okay, great. So that's great. We're going to tell a person when they're created, you are initially in this state. We're going to give them that parameter value. Does that make sense? Okay, now we just have to operationalize it, make it actionable. How are we going to do that? This, ladies and gentlemen, comes down to the crux of the issue. This, ladies and gentlemen, is the second wing of the bird. The first wing is the parameter. The second wing is making that parameter actionable. Okay, so let's do that. What I'm going to do here, we're going to engage in surgery, ladies and gentlemen, not on yourselves, but on the state chart. So we're going to drag these two things. Oh man, it's connected in a. Okay, fine. Hey, come on, get out there. Okay, there we are. We've just disconnected it. Do not worry, we'll soon reconnect it as an open heart surgery. Okay? Okay, so ladies and gentlemen, we have the state chart. We're going to go down to the state chart area where we will drag in something we have never yet seen before, called a branch. A branch. And this branch is very important. It allows us to choose when we're transitioning these state charts what happens. Okay? So there might be, for example, maybe I'm exposed to someone else's physical activity, and I'm either they influence me and I join them, maybe I join them in terms of social support, or I don't. And we might capture that with a branch, right? Someone else is around me, and they say, do you want to go jogging? Or do you want to go, I'm going to go play squash. Do I join them or not? We might capture that with a branch. But now our situation is a little bit simpler. We just, when they enter the state chart, we'll either choose one or the other. So one branch of this will go to normal glycemic. The others, ladies and gentlemen, where do you think it will go? To diabetic. We're dividing people up. Now, as I put in this other branch, I'm putting in these transitions. You notice that it draws it in a most aesthetically displeasing capacity. So I'm going to double click on it and drag here so that it is wrapped around. Okay? Okay. And I'm going to go down here, and there we go. Okay, now, so this is what we have right now visually. I'm going to wait for you to catch up, and then we're going to make it correct. I'm just waiting for you to do that. Let me show how I did that again. Okay, so the first thing I did here was I disconnected this entry point. Okay, here I disconnected it from below. So I'm just going to go through that for people who are behind. I disconnected it from below there by separating it. Next, I put in a branch, just like that. Okay? Are we okay with that? Next, I drag the transition between these two. And finally, I drag the transition from the branch down to diabetic. Now, to deal with the better aesthetics and to help reduce confusion, I clicked on this guy, and that allowed me to route it around. That's purely an aesthetic matter. It's a visual matter. It is not a matter of function, but rather of how it looks and how clear it is. And I'm going to put two little handles on it and put it into position. So now that I've bent this according to our will, I will now operate upon it. Are we all together now? Okay. Okay, ladies and gentlemen, this is what we're going to do. Under some condition, they're going to go to diabetic. Otherwise, they will be normal glycemic. These dotted line means nothing less than that's the default path. Right now, this has a contradiction. There's two default paths. We need to specify a condition for one of them. And the one that will have the condition will be this one. Under what condition will this path be taken? We'll need that. So I'm going to specify to a person their initial diabetes state using that variable initial diabetes state. That's going to tell them when they're created as a new immigrant or as a bird or at the initial state, it's going to tell them what state they're going to be. Under what condition would they start diabetic? Can anyone give me the condition? I know you've never seen this before, so you may wonder why I'm asking you, but it's not too far off from what we've done. Okay, so it could be based on those things, but in this case it's very Simple. We're going to tell them if they're told to start in the diabetic state, then we will put them in the diabetic state. So if they start initially diabetic, remember this can hold two values. Remember this is drawn from all of these values, and if we go here in projects, initial diabetes state has two possible values. So this parameter has two possible values. The set of all possible values are told by its type, initial diabetes state. And if we go look at that, that has two possible values. It can take on two values, this parameter. Initially normal glycemic, initially diabetic. If it is initially diabetic, we will go to the diabetes state. Okay, now, we are putting off, we're slightly deferring what fraction will be diabetic, etc., and we'll get to that in a moment. But this is initially diabetic, okay? Great. Are we okay with that? Are we okay with that? Okay. So if they're initially diabetic, they'll go here. Otherwise, they will go here. So we'll divide up that population according to diabetes status. And we can do the same thing with normal and underweight, overweight, and obese. And perhaps we'll want to do so. Okay, ladies and gentlemen. Great. So now, this is a parameter we have now, initial diabetes state. Where does a parameter get specified? Where do its values get specified? There's two places here, but both have to do with the thing that creates the people. Where is that? It's the population here. There we go. Okay, great. Great, okay. So this is where we specify the initial diabetes state. Now give me one way. Let's suppose there was a... Yeah. Mumble. So let's go to main and let's go look at population. Okay, let's go look at population. And then, mumble, I don't know. Okay, ladies and gentlemen, suppose 2% of the population is initially, of the immigrant population, suppose we want 2% of the initial population of the model to be diabetic, 2% of it. What's one way that I could do that? We saw it yesterday. Remember, we wanted to have a certain fraction be male and female. How do we do that? With a okay. We put into place do you remember? We had a certain fraction, 51% that were female, 49% male. What did we use for that? A custom distribution. With my students, I play, do you know, do they have, does Australia have a game called Hangman? Yeah, you fill in the letters. Say it starts with a C and ends with an N and it has a D in the middle. And they normally pick up on that pretty quick. For all I know, the young people these days have a Hangman app. So for the initial diabetes stage, we could use a custom distribution, or we could do it a different way, a slightly different way that reflects the fact that it's dichotomous. How many people would like to do it with a custom distribution, just to see that again? You want to do that? Okay, I'll say the ayes have it. Okay? Okay, this is good. Okay, so let's do a custom distribution. So we'll go to main. I like building up our existing strings. Go to main. We're going down main. And we're going to add a custom distribution in, which will be initial population diabetes distribution. So where do we, from whence does a custom distribution come? from the agent palette, indeed, will drag in a custom distribution. This will be called initial pop. Okay, I know you folks like initial pop diabetes distribution. You may want to call it, DM distribution for diabetes, mellitus, what have you. Okay, initial pop distribution, initial pop diabetes distribution. Okay, ladies and gentlemen, I would draw your attention. Yesterday, ladies and gentlemen, we were expanding our tool set. We were adding to our vocabulary. We learned A, B, C, D, and eventually by the end of the day, we got to Z. Today, we're going over a lot of the same characters again and again that we saw yesterday. Parameters, custom distributions, options lists, events, state charts. We're sort of rehashing it because that's the way AnyLogic is. We've actually done a very large part of the operating toolbox for AnyLogic, and we're just emphasizing how these things are used. Okay, so you will remind me yesterday, do you remember what we did when we needed that distribution between men and women? What did we put here? What did I put for the type? Does anyone remember? Was it continuous, discrete, or options? Option. It was option. That's right. So we're going to put option there again. Okay? There we go. Ready? Okay, and what's the option list we want to use here? We're trying to specify the diabetes population. The option list will be initial diabetes status. Okay, and so let's suppose that there's 98% who are normal glycemic and 2% who are diabetic. There's our distribution. And I said yesterday, if you've got a multivariate distribution rather than specifying the joint, you can decompose it into products into conditionals and then marginals. Okay. Anyway, okay, 98 and 2 are our values. Okay, great. Initial population. Does that make sense? Okay. So, ladies and gentlemen, now you tell me for the population, for the initial diabetes state, how would I get? So now I have to tell this person, the initial population, are they diabetic or not? What do I have to put there? I have to put, I have to draw from that distribution, initial pop diabetes distribution. You'll notice this thing with the begin paren, end paren. You'll notice this there. That reflects the fact that, again, we're asking it to do work. We're calling it. We're saying, do this, and it's returning a value. So it doesn't need any information to do its job, but we got to push that to tell it we're asking it for something. We're requesting that it do something. Does that make sense? That's why we put that. If we left that out, it would get all confused. We'd be giving it the distribution, not a value drawn from the distribution. We wouldn't be asking it for a value. We'd be just saying, for initial diabetes state, use this whole distribution. I can't use that distribution. For this person, they have a particular initial diabetes state. You can't give me a distribution. You have to draw a value from it. So here that we're basically drawing a value from the distribution, and we do so by calling it. Are we okay with that? What's that?
Sorry.
No semicolon.
No semicolon here or what those
Yeah.
I'm just trying to get.
Okay, excellent. So I love the question. Remind me of the name? Your name? Sorry?
Mary Lou.
Mary Lou. Thank you, Mary Lou. So Mary Lou's question is a common one, and it's one that bears a lot of emphasis. Semicolons are used if you're telling AnyLogic, do something. You don't need a semicolon if you're just finding a value. If it wants a value, you don't need a semicolon. Here it's asking for a value. It's saying, what's, for this person in the population, and the initial population is being created, what's their initial diabetes status? It's not asking, it's just asking for a value. This is like a formula, so you don't need for formulas, you don't need semicolons.
Okay.
It's when you tell AnyLogic, do this, add this person to the population, set this variable to be black. Set this color variable to be black. Set this hazard rate to be this thing. We're telling it, do this. We're not telling it, don't you calculate some value. We're telling it, do this thing. That's when you need a semicolon. Is that helpful?
Yeah, but it's a command.
It's a command.
Yeah.
You're saying, like, do this thing. And that's when you need a semicolon, okay? Great question. Okay. Okay. Are we okay with this? We okay? You want to run this model? Let's build it. Build early, build often. Okay? Okay, there we go. Hey. Okay? Oh, look at that. It's got a problem. Oh, look at that. This is a good thing to experience together. It's better than experiencing it alone. So you notice that when it's complaining about something. It's complaining about something that's a very real thing. The instructor was neglectful. Okay? So, but I can turn that neglect into a teaching moment, a teaching opportunity. Okay? So let's go to the problems window. It's saying it's unhappy, build completed with errors. And when that happens, you want to attend to those errors. Because chances are it doesn't understand your model, and chances are you got to fix something. So over in the problems window, it tells us. And if I double click on that, it will show me where the problem is. And it's saying here that it's confused. The method add population takes two things. It's expecting a second thing, initial diabetes statement. Oh, of course. I specified for the initial population, I specified what their weight status would, or initial diabetes status would be, but I haven't yet specified it for the immigrants. I didn't specify it for the immigrants, what their status will be. What do you think their status? We could draw it from the same distribution. We could say all immigrants, by virtue of undergoing screening, are normal glycemic as a requirement. So we could say that, diabetic people are not invited in as immigrants. We could have a different custom distribution. Which would you like to do? A different custom distribution? Great. This will be quick to do. Watch this. Can I tell you a trick? A tip? Okay, watch this. Go and grab this one here. Do copy. Watch this. This will be your friend as much as autocomplete. Okay? Okay, copy this, or another way to do it is to do copy, click nearby, and do paste. And it will put this. Okay, now, we're going to need to rename it. It's no longer initial pop, it's immigrant pop diabetes distribution, or immigrant pop diabetes distribution. Okay? And we're going to specify a different value. Maybe for the immigrants, 99% are non-diabetic. They tend to be, people earlier in life. Tend to be from populations, perhaps room type 1 diabetes is not as common. But, if you think about it, there's plenty of intergenerational immigrants that come in from people bring their mother in, and perhaps, she has diabetes. And there are some individuals who do come in with diabetes, known or not known, maybe highly skilled workers. So we made it 99 and 1%. Are we okay with that? Okay, great. So now we have a custom distribution there. So now back when we add the immigrant in, what do we do here? So this is the birth time they came in, and what is their status when they came in for diabetes? How do we determine that? I will make it on the next line for ease of viewing. How are we going to specify what diabetes status they are? That's what it wants. If we do autocomplete here, it wants a birth time, and it wants a diabetes status, initial diabetes status. That's what it wants to do its job. It needs that information. So we're going to give it for the initial diabetes status. We just created it. What is it? A draw from the immigrant diabetes distribution. There it is, okay? immigrant pop diabetes distribution. There we go. Ladies and gentlemen, that's it. Let me go put this up on the big screen so you can see it. There it is. I use the comma. Why is the comma? Because the comma is there if we have to give multiple pieces of information to it. You need to separate them by commas here. You know, if you need to specify, you need to say move to this point, X and Y, say X comma Y, right? That's why the comma. Same syntax in SAS or R or any number of different packages. You put commas. Now, the thing that was a little bit different, and this was purely my preferences, I put these things on a different line, and that's mostly because I didn't want it to be invisible, like to wrap around off the right-hand side here. I didn't want it to be invisible. So I put them on separate lines. And it doesn't care about the lines, but visually it's a bit easier. If you have many parameters, you can list successive ones on different lines. It's kind of nice. Okay? So I put the comma here, and then I indented this. Okay. Yes. Yeah.
Just as a general point, if you're in this instance where you're asking the population, does the kingdom just come from specify initial parameter value for all the parameters that are in the model?
So if there's a parameter in a person, as a general rule, we want to specify. It actually doesn't totally absolutely require you to. You could basically say, just use the default value. But so you can say that, to use all default value for all the parameters. But as a general rule, when you're adding someone to the population, you care about their characteristics. You care what diabetes status are, what weight status, what education, income, etc. Does that make sense, Alan? Yep. Okay, so ladies and gentlemen, build the model here. Okay? Okay, great. Okay, so should we run the model? Oh, okay. Oh, it's still got, okay. Mine's okay. So do you have an error here? Can I check? Okay. So, okay. So that should be fine. So let's do, can you save your model? And then do this. Okay, it's an unhappy camper. Okay, add population is not applicable for, oh, I know why. Okay. Folks, I would like to draw your attention to something. Okay? I'd like to draw your attention to a point of note. This within person, just as a double check, and Dylan, you might want to make sure of this. Within person, initial diabetes state, make sure that its type is initial diabetes state. In other words, for this parameter within person, the possible values it takes on must be those specified by initial diabetes state. You can't give it any arbitrary double. You have to give it one of those. So within person, yeah, within person here, you have this parameter. Where is the parameter that was added to person? Let's go down. Parameters. Here they are. Okay, it's over there. Oh, look at that. Look at that. Okay. Oh, I know what it is. Okay, sorry. My hypothesis was wrong about the cause of the issue, but now its cause is evident. This thing here needs to... Okay. Oh, no. Okay. Mumble. Okay, this is fascinating. This is fascinating. Okay. I need to. Okay. Okay. It's not applicable for types double. It's like it. Oh! I know why it is. It's this. This is not called immigrant age distribution. It's immigrant pop diabetes distribution. So do, and now control space, and it'll be your friend, and this is what we want, okay? And then we don't need these two guys here. Is that okay? Okay, who else needs help? Okay, okay, why don't you run that? Okay, let me get to this one and I'll come around, okay? Okay. Ever get mob diabetes distribution? That's because you have a 1 at the end of it. See, there's a 1. And so the easiest thing to do is to do autocomplete, and it will yeah, you can delete the 1 and that will be safe. Okay, Matt. Okay, yeah, so this here, one is only one who the ball. This guy is not the function, and this needs to be the function. Indeed. Okay. So let's go look here. There we go. And now let's see if they have. But then there's a person. Whatever happens to so I have a couple theories of what's going on, okay? One theory is it's there and it's covered by lines. Another theory is it's there and it's small. What does this mean? Like, either he's tiny, he's not just covered by lines, either he's super small. Let me just go zoom in. Is there a tiny little man? No, it's just his scale. Okay, I'm guessing that it's something like this. I'll put a shape on it. And then let's go look down here. Scale it, scale what you want. So the theory is that he's maybe invisible right now for some reason. He's small, maybe he's, I like your idea that he's white. Maybe, okay, temporarily change this to black. That's it. Let me just change this to black. Remove that and run it. Hey, go color black. Okay, black. Okay, can you run it? Okay, and then let's do this. Okay, no, it's not nearly white. Okay, okay, so that was a great idea, but first he is not, nice. So the scale is not being overridden here. Okay, so we could add a new one. Okay, let's just do a Sandy check here. Okay, I'm going to add in an oval here, just to sort of come with this. And then I'm going to go to person, and I'm going to go to population. It's scroll down here, and then I'm going to go see if that is visible. Basically, I want to see is it a problem with the icon? Okay, so there you go. Yeah, there he appeared. Okay, so is it possible you added the little man after, you added it backhand later, or something like that, or you added, okay, there it is. Okay, yeah, there's something that went on. Basically, if you if you add the image later, you have to tell AnyLogic, hey, I added an image. You do that by going to population, going down and doing show presentation. And maybe something went on where you deleted it and then added it back and then it fell. But anyway, that's it. Okay? Okay, great. Oh, wonderful. Okay, I hereby declare a beef brick. That's great. Okay. Okay. Emergent breaks. This is good. Okay. Yes.
Can I get a copy of your model so I can go around to other people and you can pass it off to them, or we can put it on the website right now?
Yeah, I can do that.
Other people are in some deep trouble and will need a new copy.
Sure. Okay. What happened by and large? I see. Sure. Sure. Okay. Yeah, we'll do. We'll do here. Thanks. Yeah.
Caterers want to know, because we're having on tea, should they delay the lunch because it's hot food, so they want to bring it
Right.
to us at the right time? What do you think?
Delay it from 12:30?
Yeah, or it can come at 12:30, or we can delay it till 1, whatever you think. Whatever you've got planned in the next session.
Yeah. Yeah. Let me just think here.
I'll let you finish what you're doing.
Okay, okay, yeah. I want to, thanks very much. I want to get this model up to the website. Okay. Thank you. Thanks, Jeff. I really appreciate that. Okay. Okay. Okay.
Too much information.
Okay, okay. Do. Okay, so folks, I'm putting up by request, hopefully passed on by Dylan, I'm putting up here the latest version of this model for downloading via the site.
Do you want your screen shown?
No, not yet, no, thanks. Okay. Okay, so it's exhibiting, okay, there we go. Okay, and, okay, great, and there we are. Okay. Okay. Okay, so now Dylan, you can show the screen. Thank you. Okay. Okay, so it's. So you set it to laptop? Okay, there we are. Okay. Thank you. Okay, so ladies and gentlemen, I did post that latest version of the model to this place here. So interaction of weight and diabetes, Melbourne. I note that it's version 2 here. Okay. So if anyone would like to have a fresh start, would like to start with the model in its latest rendition, just for the break, you can go obtain it from this location on the site. And I would note that we have this tiny URL I gave to get to the site. Does anyone need that information? Oh, the tiny URL is over there, just behind.
Give people a minute or two to get that and download it if they want to have it, rather than going ahead. I think that will stave off a lot of issues.
Yeah, that's great. Thanks. Okay. Any questions while people are downloading that or taking a look to to get that all loaded up. Any questions? Okay. Okay, so I'm going to go and load it up. I had to move it to a new location to do that. And here we go. And there we are. Okay. And I will now call this going forward so that we have reference to this intermediate point. I will call this version, going forward, I'll call it version 3. Okay. Save as version 3 here, okay? Great. Oh, okay, now I have to be careful here. Let me make sure this is the very latest changes. Because, yes, no, that's right. Yep, that's the one. Okay, great. So I'll do save as, and I'm going to do version 3, and this will be in yours as well. There we go. Okay. Any questions?
Maybe just trying to find the right document.
Sure. Okay. So the right document would be, if we look at, so there's participant resources. This is to the area to which your tiny URL draws you. That tiny URL that's on the thing there, and what you need to use is models built during class. Oop. Hey, come on. Models built during class, and then it's this last model here. So do you have that? Are people all set? Anyone need Delanian help? Nolian excellence? Okay. Okay. Sorry?
Sorry, what was the path there? Is that,
It's, so again, it's participant resources here, and then you go down into models built during class, and then version 2, Dylan?
interaction of weights.
In diabetes, Melbourne, MC1, the version 2 at the end. One is the version from yesterday, one is the version from today. Okay, are people okay? Who else needs help? Dylan, we need another minute or two?
I should be fine over here.
Okay. So, ladies and gentlemen, I should note the second TA was expected to arrive just about now. But in a bizarre irony, I think Joanne, you heard about it. Her flight from LA across the Pacific was canceled. Yeah. And she was delayed to a flight exactly 1 day later. An insult that has also befallen several others that I know. And I lack the full reason why. The claim was, I know the younger generation has its issues, but I'm not going to put the blame on them in this regard. But the blame was that the flight could not leave, could not cross the Pacific could not be made because the entertainment system was experiencing difficulties. I don't know which airline it was, but I wouldn't have thought that was a catastrophe at the level that would prevent a flight from going along. But we could have given them all AnyLogic. Could have had a real master class. Could have gotten to lofty topics in the course of that flight. Okay. In any case, the TA has been delayed 1 day. So if we're lucky, she might probably still awaiting the flight. Right? Probably another few hours and stuck in a hotel to go back to the airport. Okay. So, ladies and gentlemen, we have yet to complete our thought. And I would like now to proceed to add to this model the final coup de grace with respect to the this issue of open populations. To wit, mortality, and actually we have to do births as well. So that's mortality is not the sole coup de grace. Okay. So great. So let's go into person and let's think. Well, let's think about things. How did we capture? How did we? Let me make sure this is being recorded. Okay, I'm not sure I need